Right, so it's quite likely when you think of generating with water, the first thing that springs to mind is hydroelectric and dams and water wheels and turbines, because that's certainly what I think about. But in the last few years, that's kind of changing. And what they're looking at is water generation with this stuff, damp paper. Now, paper is made of cellulose fibres. It's either chopped up wood or chopped up rags, it's cotton. But the fibres in wood and cotton are cellulose, and cellulose is just a long-chain sugar. It's a polymer of sugars, and it has an awful lot of OH groups and O groups sticking off of it, so carboxyl and hydroxyl groups. Now, carboxyl and hydroxyl groups have a curious property that if they get damp, then the hydrogen, the H+, can dissociate from the chain and migrate, leaving behind a negative charge and a mobile positive charge. Then it'll do that against a concentration gradient or against a moisture gradient. So if the paper's more damp on one side and less damp on the other, then you will get this migration of positive charges, leaving it positive one side and negative the other side, in association with generation of an electric current. And that's absolutely fascinating. And it's fascinating an awful lot of people, and an awful lot of research is now going onto this, and they're calling it moisture-enabled generation, or MEG. It's difficult to tell whether this is more linked to traditional hydroelectric generation or it's more linked to a battery, because you can start to think of those kind of devices as moisture charging or self-charging batteries, or you can think of them as hydroelectric generators. It's kind of halfway between the two. Now, what's stunning about them is how simple they are to make. You really need nothing at all. You need a piece of paper and a current collector on one side with holes in it so the moisture can get in, and a current collector on the other side with no holes in it. Then when moisture, either from your air or even from just breathing into it, goes into that paper, it will generate a current. And there's a whole range of generation available from sort of 0.1 of a volt up to about 0.9 of a volt per unit that you make. Now, the amount of current isn't huge. The biggest recorded one was 450 micrometers, or more or less half a millimeter, on a 1 centimeter square. Now, for a 1 centimeter square device, that's actually quite stunning, particularly when you think about the price of paper. Then the generation capabilities have got everybody very excited, and they're starting to look at doing things like titanium dioxide nanorods, graphene oxide, forward carbon black. Just all kinds of things have been investigated for this curious hydroelectric generation based on thin films and based on papers. So quite simply, the easiest one I could find was this one. It's called Electric Power Generation Using Paper Materials, and in that paper, which is freely available incidentally, in that paper you can see that these guys just used paper, showing this thing could work. They then linked up 5 of them and ran a calculator off of this 5 square centimetres of paper moistened by a breath. So in order to try this, I've got a rough and ready experiment. I've got 2 bits of aluminium that is usually used for car repair and a piece of paper. We'll put that paper on there and that on there, and I'm going to blow on it and see if I can generate a voltage. And indeed, it's generating about 150 millivolts. Now, that's from the moisture in my breath. The more the humidity difference, the greater the voltage goes up. The higher the temperature, up to 40 degrees centigrade, the greater the voltage goes up. Another way of increasing the voltage is to do what they did in the paper, and that's to soak this in 1 mole of hydrochloric acid. That increases the number of available protons on there for that transport mechanism, and it makes a significant difference, getting about 0.8, 0.9 of a volt. And they connected 5 together and got something like a milliamp out of it. It was enough for them to be able to use a small calculator out of those 5 things joined together.